Hey guys, thanks so much for giving me the opportunity to speak here today. I am Frank Macreery. I'm the CTO of Aptible, and today I'm going to talk about how we use containers at Aptible to achieve security and compliance objectives on behalf of our customers. So Aptible is a platform as a service for HIPAA compliance. What that means is we have a container scheduling system where our customers deploy applications, databases. They run their entire infrastructure on top of us. We complement that with a set of SaaS products that manage the administrative tasks related to HIPAA. I'll talk more about the PaaS architecture later, but first, I'm going to start with a brief overview of HIPAA, and I promise we'll keep it brief. Who here has heard of HIPAA? OK, wow. So pretty much everyone. So what is HIPAA? It's not related to hippos, so if you were misled about this presentation, I'm very sorry. It has to do with protected health information, or PHI. So PHI is data that's created or received by a healthcare provider or a health plan, so a doctor or an insurance company. It relates to your health or your physical condition, how healthcare is provisioned to you, or how you pay for it. And most importantly, it identifies you as an individual. So HIPAA is a legislation that regulates how the privacy and security of this type of data needs to be maintained. HIPAA applies to a variety of companies and organizations. So the first class of companies is covered entities. So this is health plans, healthcare clearinghouses, and healthcare providers. So these are the ones that you're most familiar with, your doctor, your health insurance company. It also applies to business associates, which are entities that create, receive, or transmit this protected health information on behalf of one of those covered entities. So these can include companies like ZocDoc that help you book an appointment with your doctor, or Zenefits that helps you obtain health insurance. They also include companies like Omada that provide direct access to medical professionals. It includes companies like Flatiron or Doximity, who build tools for doctors and workflow tools for doctors and medical researchers. Because of the fact that HIPAA applies all the way down to where data is stored, business associates also include hosting providers like Amazon Web Services, Google Cloud Platform, Rackspace, Azure. And finally, with the rise of health and wellness apps and frameworks like Apple's Health Kit, any app that shares your data from your mobile device with a medical professional or insurance company is also a business associate. So as of 2013, HIPAA changed. And very importantly, all those companies that I just listed as business associates became regulated by HIPAA almost overnight. So it's not just a legislation that applies to only doctors and insurance companies anymore. So that's who it affects. But why should those companies actually bother complying with HIPAA? There is, I guess the short answer is there's a stick and there's a carrot. The stick is the Office of Civil Rights, which is the enforcement arm for HIPAA. So OCR conducts random periodic audits to make sure that the regulated companies stay compliant. In 2014, so we don't have full data for 2015 yet, but in 2014, there were 14,000 enforcement cases, which was up 300% from the previous, from 10 years prior, and it continues to grow. 24% of these cases resulted in corrective action, which is euphemistic for a lot of fines. So the fines include direct breach and remediation costs of up to $200 per record. So this is per patient record that's involved in the breach. That doesn't include damages sought in class action suits, which average $1,000 per record. And then on top of all that, a fine of $1.5 million can be levied for each provision of HIPAA that's violated. So that's a pretty strong stick to compel us to comply with HIPAA. But there's also a major carrot here, which is that by complying with HIPAA, a company can make itself very attractive to enterprise healthcare buyers. And so with that, let's talk a little bit about what managing compliance involves. So we're going to talk about it. We're going to build to the way that we do this at Aptible using containers to standardize security. But let's just talk about what some of the requirements are. So the first set of safeguards under HIPAA are physical safeguards. So this includes things like facility management, having biometric sensors in place on actual physical data centers where servers and disks live. Physical contingency plans, so operational plans that a provider like AWS would have in the event of a natural disaster. Fortunately, for us and for any other company that's deployed in the cloud, your cloud provider, be it AWS or Google Cloud Platform, is covering almost all of the physical safeguards. Then there's technical safeguards, which are technical implementation details to manage security and privacy. So this includes encryption of PHI, both at rest when it's stored on data volumes and in transit, data availability and backups, and authentication and authorization, so access controls for instances, databases, other services. So this is kind of the core service that Aptible provides on our platform as a service. And then, of course, there's administrative safeguards. This is mostly procedural paperwork related safeguards that include things like policies and procedures, so having manuals in place for your entire company, conducting risk assessments on an annual basis, administering training to your entire workforce. So that happens to be something that Aptible also covers through our SaaS product. That's a bit out of scope of what we're talking about here. We're going to focus on technical safeguards. But of course, if anyone has any questions about what these administrative safeguards are, just ask me after. So what does compliance look like in this year, the modern era? So for the most part, compliance is still administered through security assessments, which generally take the form of Excel questionnaires. And they look something like this. So this is actually the state of the art in security assessments today. This is the Cloud Controls Matrix, which is put out by the Cloud Security Alliance. So this is an industry-agnostic security standard that companies like Google, Microsoft, Amazon have put together kind of as a least common denominator that covers all other security frameworks, be it HIPAA, PCI, FINRA, FISMA. And the idea is that by answering all of the questions on this Excel spreadsheet, you have a direct mapping to every other regulatory framework you need to comply with. And that's really, I mean, for an Excel spreadsheet, that's sophisticated compared to what it's been like. In practice, though, most companies still have many custom or industry-specific security assessments to deal with. This is one from a major healthcare provider, UHG. And on average, every single one of our customers that's selling into hospitals or insurance companies has dozens of these questionnaires to fill out, in addition to CCM, to HIPAA's self-assessment. And most of the time, the majority of companies out there are still managing this compliance by manually documenting all of the security procedures of the organization, getting engineers and compliance officers in the same room and writing everything down. And those meetings generally look something like this, as you can imagine. So to turn it into some math, we've got dozens of security assessments and countless applications that we've got deployed in the cloud that need to be audited, and it just creates tons of headaches. But containers can help this problem by providing a natural way to standardize infrastructure. They're easier to set up than VMs, so they can be used for smaller pieces of infrastructure. They're fully encapsulated, and they're immutable by default, so you can plug them in and know how they're going to work. And the Tectonic ecosystem provides many extra tools for auditing and securing containers. So you aren't doing this by yourself. You have a lot of help. So to illustrate the power of containers, I'd like to walk through two use cases from our systems at Aptible. and ways that we use containers to standardize our systems and manage security and compliance. So the first is our containerized SSL implementation. So just to illustrate how we use SSL at Aptible. This diagram illustrates kind of the request flow for a customer Rails application that we're hosting. So we've got several Rails application containers that are distributed across multiple EC2 instances. And in order to minimize the number of places where we have to deal with SSL termination, we just pass through the HTTPS requests as just plain TCP traffic from elastic load balancers that AWS manages to Nginx containers that we run on the same instance as the customer application containers. So we're only terminating SSL in one place at these Nginx containers. There are a ton of different ways to configure Nginx with multiple dynamic upstreams. This is something that a lot of companies do. You could use Chef, Salt, Ansible, any number of server automation technologies. What we do is we use a container that is configured via environment variables. So for example, to configure the way that an Nginx container reverse proxies its requests to application containers, we just use an environment variable upstream servers. And so again, these examples use Docker, but it's really agnostic to the container runtime. So we can just pass in a list of upstream servers, and our Nginx container knows how to process that. This has a few advantages. For one, it makes testing easier. One thing that we do that's a bit unique is we run all of our integration tests for our containers inside the container build process itself. So we use BATS, which is just a simple bash testing framework to do this. It's very simple. You just write all of your tests as bash functions. If they exit 0, it's a passing test. So inside a Docker file, we include a couple lines. One to include our test examples, and another to run them. So in order for the container to build successfully and in order to build an image that we can actually use, it must have passed all of these tests. And so we can test things like the basic functionality of this reverse proxying. And to do so, we can just specify an environment variable. It's pretty easy. We can wrap this in bash functions. So basically, we've got just this testing library to make sure that all of our containers are behaving exactly as we intend them to. Another benefit of this environment-based configuration is that it actually abstracts away the implementation details of how we're implementing SSL termination. Right now, it's Nginx, but it could be Apache, HA proxy. So long as the API for these environment variables is the same and is maintained across these containers, we can swap in any technology. It also simplifies configuration management in that the central store doesn't need to know parameters in advance. So we can add capabilities to the container as we need to. And so we can include security parameters, such as forcing SSL, disabling weak cipher suites. We have a host of others. Those are kind of the two highest level ones that customers use most often. Using an a standard SSL container also simplifies our vulnerability response process, which is an important part of our security program. So basically, we fix the vulnerability, write an integration test for it, push it out to our Docker registry, and restart the containers all across our infrastructure. So we've done this in the past for Heartbleed, for Poodlebleed. We'll probably do it for several more OpenSSL vulnerabilities in the future. But basically, the approach that we've developed is that we use integration tests to document every single vulnerability response. So for example, for Heartbleed, we have an integration test that installs Philo-Sotilli's Heartbleed checker, spins up the actual Nginx process inside the container, and tests that it's successfully mitigating Heartbleed. Part of the benefit of doing all of our builds on Quay is that these integration tests happen on every single image build and on every push to GitHub. So we have our GitHub account for this Nginx Docker image linked to Quay. It automatically builds via Quay build triggers. We get a beautiful log of every single build, so we can refer historically back and see exactly what tests were run, have clear documentation for even a non-technical person. We can easily verify the build status and the status of all these security tests across every image that we host. So when we log into Quay, we see something like this, just a lot of red and greens. So we know how to triage and prioritize fixes. The Quay time machine feature allows us to roll back an image to any previous state, and also to identify exactly what image was being used at a particular time. So we've got this amazing audit log. We can determine exactly what was running, and if we want to quickly revert to an old version, we can do that. And then most recently, the security scanning feature, which is in beta, gives us an externally verified view of vulnerabilities. So when we log into Quay today, we get a view of CVEs that have been identified in the packages that are installed in our image. And this all comes for free. This is part of the ecosystem that we don't have to build ourselves. So that's one of the use cases for standardizing our deployment through containers. Another example, or another use case I'll go through, is our approach to database security, which is to support many database technologies, but have one security strategy for each. So things that are related to database security, and more broadly, security and availability that HIPAA is concerned with are authentication, encryption, both at rest and in transit, replication, and backups. So on the Aptible platform, we support and administer a wide variety of database technologies. Part of the reason for this is our customers don't have any good HIPAA-compliant alternative for things like Elasticsearch, Redis, CouchDB, or RethinkDB. Solving all of the security and availability problems ad hoc for each one of these database technologies would quickly become too complicated and too brittle. So the approach that we've taken is to standardize our database containers. So we use containers to wrap all of the databases that we support with a common entry point and a shared command API. So we basically take the database and then wrap it with shell scripts to have a common API. So I'll go through a couple examples. So one thing that we do whenever we initialize a database container is we set up authentication. We set up an initial user. So I'm just going through that small example here. So this is how we might do so for Postgres. So basically, loading in a set of volumes from a volume container, specifying a username and passphrase for initialization, and then calling this -- initialize flag. And then inside the scripts, the entry point for the container, we've got this script that responds to initialize. And when it sees that flag, it creates the Postgres data directory and creates a super user with the user and passphrase that we specified. So again, it has this format. But what we can do, because we've standardized the way that all of these databases run, is we can use the same exact command, but just substitute in a different database and have the exact same workflow and the same API. So this, for example, is what the same entry point, the -- initialize entry point looks like for MongoDB. So a similar process, initializing the database, initializing a DB owner role user, And so that's this -- initialize flag. We've got a few that are related to security and replication and backup. So we've got initialize, activate leader, initialize follower, dump, restore. There's several others, but the key is that it's exactly the same across all of our database containers. We take a similar approach, although a little bit different, for accomplishing encryption at rest. And for this, we end up piggybacking on the volume metadata that can be built into an image. So what we do is we treat any volume that's specified in the Docker file and load it into the image metadata. We interpret that as a volume that needs to be mounted on an encrypted file system. And so the container orchestration system is responsible for setting all that up. But the container has the contract that it specifies on which volumes its sensitive data live. So this is what it looks like for Postgres, where we specify the Postgres data directory, and the container can have faith that that gets loaded on an encrypted file system that gets periodically backed up as needed. We have the same thing for Elasticsearch. And so again, we use the volume metadata to communicate encrypted file system requirements. And that's all part of the container API. We didn't have to build any of that. So that's a bit of a view into how we are able to simplify database availability and security through standardized containers. So having many databases and just one strategy. That's all I've got for now. Just a quick view into like how we use containers to implement security and compliance. But if you guys have any questions, I'd be happy to answer them now or take questions afterwards too.
Hello. Yeah. You talked about configuring your containers with environment variables. How do you get your SSL private key into your Nginx for SSL termination?
So that's a good question. So Jake asked, if we're using environment variables, how do we get the SSL key and certificate loaded into the container for basically setting up SSL termination? So that is a little bit different here. So there's a couple ways you could do it. You could load it in via environment variables. We actually, I didn't go into it. We use an encrypted volume, and it's mounted in there and loaded in. That part is part of the orchestration that we do. That isn't kind of automatic, unfortunately.
So you talked about running your integration tests at build time. Presumably that results in like test cruft being actually in the container that you ship. Is that add much to the image size? Is it a problem at all?
That's a great question. So the question is, so by running our integration tests at build time, does that increase the cruft and size of the container or the images? In our case, in some cases, yes. There's approaches where you could run the tests and then immediately remove all artifacts. So have it be a single self-contained run command that sets up the test scaffolding, runs the tests, and then cleans up. That's one way to approach this. Other people approach this by having a build and a deploy container that are separate containers. So you basically have a build container that is bloated and oversized, and then you have a set of processes that copy out the necessary files and libraries into a deploy or a runtime container. So then your deploy container is about as slim as it can be. We have not done the second approach. I know of people who do.
Excellent.
Cool.
Well, thank you, Frank. That's extremely helpful for people to be able to kind of both get that type of information and hear from somebody who lives in that type of compliance world how these pieces all fit together and the utility of it. So.